Use the elimination method to solve the system of equation 5x minus 4y equals 4, 3x minus 6y equals 24. To use the elimination methods is to first find the same amount for a certain variable in both equations, either x or y, and ideally we want to have the opposite sign so that we can add the two equations. If not, we can just simply subtract the two. Ideally, we don't want to work with fractions. So for example, yes, we can turn the second equation into 5x by multiplying 5 over 3, but then we would introduce fractions. To avoid working with fraction, we would find the least common multiple. It doesn't matter which variable we eliminate first. Let's say we want to eliminate the variable x. The first equation has 5x and the second equation has 3x. The least common multiple of 5 and 3 is 15. The goal is to turn the 5x terms into 15x and 3x into 15x so that we can subtract the two equations. We're allowed to multiply a non-zero to both sides of each equation to obtain an equivalent system of equation. If we take the first equation and multiply 3 because we want to end up with 15x, then the first equation is now 15x minus 12y equals 12. We need to multiply 3 to every single term on the left and on the right hand side of the equal sign. We use the second equation and multiply 5. 3 times 5 is 15, so we have 15x. 6 times 5 is 30, negative 6y times 5 is negative 30y. And don't forget to multiply 5 to the constant term on the right hand side of the equal sign as well. 24 times 5 is 120. We now have a system of equations with the same amount of x. Since they both positive, we subtract the two equations. 15x minus 15x is 0x. Negative 12y minus negative 30y is negative 12 plus 30y, which is positive 18y. And 12 minus 120 is now 108, but negative because we subtract the second equation from the first equation. Now that we have an equation in terms of y only, we isolate y. Y equals negative 108 divided by 18. So y is negative 6. 6 times 8 is 48. 6 times 1 is 6. 60 plus 48 is 108 negative. Once we obtain y, we perform a back substitution to find x. It doesn't matter which equation we use to find x. If we use the first equation, then we have 5x minus 4y equals 4, where y is negative 6. This is 5x plus 24 equals 4. So 5x equals negative 20 because we subtract 24 from both sides of the equation. X is negative 20 over 5. So we obtain x equals negative 4. We then check the answer. The first equation, 5 times x, x is negative 4, minus 4 times y, y is negative 6, and we want to know whether this is 4 or not. Negative 20 plus 24 is positive 4, so this checks out. The second equation, 3 times x, x is negative 4, minus 6 times y, y is negative 6, And we want to know whether this is a positive 24 or not. 3 times negative 4 is negative 12. 6 times 6 is 36. Negative times negative is positive. 36 minus 12 is positive 24, so it checks out as well. We conclude that the solution to the system equation we're looking for is negative 4, comma, negative 6.